Implicit differentiation and related rates. There are two ways that we can define y as a function of x. First, explicitly means fully revealed, expressed without vagueness or ambiguity. Y equals 6x minus 2, y equals 3 over x squared are examples of explicitly. Implicitly means implied or understood though not directly expressed. 6x minus y equal 2, yx squared equal 3 are examples of implicitly. Now, let's learn how to find the derivative of implicitly defined functions by implicit differentiation. If an implicit function can be expressed explicitly as a function of x, finding its derivative is easy. For example, 6x minus y equal 2, y equals 6x minus 2, dy over dx equals 6. Now let's find dy over dx for the above implicitly defined functions without first solving for y. To do this, we think of y as a function of x, and we take the derivative of both sides of equation with respect to x and use the chain rule. d over dx parenthesis 6x minus y equal d over dx 2, 6 minus dy dx equals 0, dy dx equals 0. 6. Third example, determine the derivative of dy over dx for 7x squared minus 4y squared equals 24. Step 1. Take the derivative of both sides with respect to x. d over dx 7x squared minus 4y squared equals d over dx 24. 14x minus 4, 2y dy dx equals 0. 14x minus 8y dy dx equals 0. Put all of the terms involving dy over dx on one side of the equation and everything else on the other. So 14x minus 8y dy dx equals 0. Let's move 14x to the right. So minus 8y d over dx equals minus 14x plus. Step 3. Factor out the dy over dx and solve for dy over dx. dy dx 8y equal 14x. So let's divide it by 8y. dy dx equals 14x over 8y. One of the most important applications of implicit differentiation is solving related rate problems. In these problems, two functions of the same variable are related by some equation. We use implicit differentiation to take the derivative of both sides of the equation, and we end up with an equation relating the rates of the change of two functions. This is why these problems are called related rate problems. There is example question of related rates. Suppose the shape of an oil spill from a ruptured oil tanker takes the shape of a circle whose radius increases at a constant rate of 5 feet over second. How fast is the area of the spill increasing when the radius of the spill is 2,500 feet? Step 1. Identify all quantities and draw a sketch if possible. So R equals the radius of a spill and A equals the area of the spill. A and R are functions of the time t. Step 2. Write an equation relating the quantities from step 1. Since it's asking for the area of the circle, the equation is A equals pi r squared. Step 3. Use implicit differentiation to find the derivative of both sides of the equation from step 2, which is a equals pi r squared. D over dt area equals d over dt pi r squared. dA over dt equals 2 pi r dr over dt. Step 4. Solve for the desired derivative and plug in any remaining values. dA over dt equals 2 pi r dr over dt. In this case, there is nothing to solve for since dA over dt is already alone on the left-hand side. Since dr over dt equals 5 feet per square second when radius equals 2500, dA over dt equals 2 pi 2500 5 equals 25,000 pi square feet per second. So 25,000 pi square feet per second is how fast the area of the spill increasing when the radius of spill is 2500 feet. This is second example question of related rates by using implicit differentiation. Air is being pumped into a spherical balloon, causing the radius to increase at a rate of 2 centimeters per minute. So determine the rate at which the volume of the balloon is increasing when the radius of balloon is 20 centimeters. So step 1, identify all quantities and draw a sketch if possible. R equals the radius of the balloon. V equals the volume of the balloon. V and R are functions of time t. This is the draw of the sketch. This is R and sphere. Step 2. Write an equation relating the quantities from step 1. Since the question is asking about the volume of the sphere, V equals 4 over 3 pi r cubed is the equation. Step 3. Use implicit differentiation to find the derivative of both sides of the equation from step 2. dt V equals d over dt 4 over 3 pi r cubed, which is dv over dt equals 4 pi r squared dr over dt. Step 4. Solve for the desired derivative and plug in any remaining values. dv over dt equals 4 pi r squared dr over dt. dr over dt equals 2 centimeters per minute when r equals 20. dv over dt, so plug 20 to the r and 2 centimeters per minute to dr over dt. So final answer is 3200 pi cube centimeter per minute, which is the rate at which the volume of the balloon is increasing when the radius of balloon is 20 centimeters.